Hello students, again I am with you for physics standard 12th Swami Vivekananda English Medium School physics teacher. From today we will start discussion on semiconductor materials, devices, logic circuits. One of the basic chapter for the students of BE Electronics, BE Computer, BE IT. It is the base for those students. In detail, they will learn more in their higher studies. What is electronics? What is electronics? One of the definition of electronics, the branch of physics deals with the study of devices based on electromechanics. I repeat, branch of physics deals with the study of devices based on electron mechanics. So you can say, if you divide the world electronics is equal to electron plus mechanics. So this word electronics comes from the two words electron plus mechanics. Earlier, electronics was the part of electricity. In B electrical branch, some chapters of electronics were taught. But because of some inventions, discoveries like diodes, transistors, ICs, revolution came in the field of electronics. And today, electronics is one of the important separate branch. You can become scholar in BE electronics and communication. If you look around you, no area of the life where this electronics has no role. You know, in the field of entertainment, your TVs, your radios, computers, mobile phones. In education, online classes, especially for this difficult time of Corona. Already there are channels on which education is transmitted. So many medical devices nowadays, you can see thermometer, digital thermometers. Everything is revolutionized because of this electronics. मेडिकल फील्ड, रोबोटॉनिक्स, अभी हम लोग देखते हैं रोबोट नर्सेज आर देयर टू सेव योर सेल्फ फ्रॉम दिस corona. Come to the point, if you look into any broken or not working device at your home, if you open the screws, you will see basically two type of components in any electronic device: active components and passive components. Some examples of active components: diodes, transistors, ICs, because they play important role, direct role. And passive devices are resistors, capacitors, inductors. Especially we find resistors, capacitors. They are known as passive components, helping components to your electronic circuit. To understand, because we are on the first part of the chapter, we will first deal semiconductor materials, because the second part is semiconductor devices. To make semiconductor devices, we require semiconductor materials. So the basic of this semiconductor materials, on the electrical behavior, materials are classified into three categories: conductors, that is metals, insulators, and semiconductors. What is the basic about the conductors? Conductors have free electrons. Mostly in the periodic table, elements of such materials lie in first, second and third column. These are known as groups. Second category, semiconductors. They have no free electrons, and mostly they lie in the fifth, sixth and seventh group. For the stability, we know that the outermost orbit must have 8 electrons. For the groups having 1, 2 or 3 electrons, have difficult task to get the remaining electrons. So they have tendency to lose electrons. When the atom of the metal loses the electron, it becomes positive ion. So inside the metal, we find ions and free electrons. Examples of metals: copper, aluminium, silver, etc. And examples of bad conductors, insulators are rubber, wood, plastic. But there is a category materials, those lie between the two, and they are semiconductors. So our chapter will focus on this material. Semiconductors or semiconductor materials and their elements are lying in group 4. First, second, third group has tendency to lose electrons. 5, 6, 7 has tendency to gain electrons. But for the middle, fourth group, because the probability is same, lose 4, gain 4. So this group does not loses or gain. There is a tendency of making covalent bonds. You know, in chemistry there are two types of bonding: ionic bonding, that is giving or taking electrons, but covalent bonding means sharing of electrons. So this is the important property of this fourth group. Fourth group has alpha. You know, alpha is temperature coefficient of resistance, positive for metals and alloys. Means there is direct proportional effect on resistance or resistivity. But our semiconductors, they have negative alpha. Semiconductors do not obey Ohm's law. You will see this. The graph of IV characteristic of diode is not a straight line. So, semiconductors have negative alpha. These all are basic concepts to start our main topic of semiconductor materials. Why do we need semiconductor materials to prepare semiconductor devices? That is your second part of the chapter. And the last one is logic circuits. So another important property of semiconductor materials have doping. If you dope semiconductors, their conductivity increases to large extent with the help of process of doping. You will learn this in the coming topic, what is doping. So this important property, doping can increase the conductivity or can decrease the resistivity of semiconductor materials. Now come to the another basic topic of structure of atom. You know the structure of atom. There is a small central portion which is known as nucleus. हर एटम का बेसिक स्ट्रक्चर क्या है? There is a small tiny portion region where protons and neutrons are present. And this portion is known as nucleus. Around this nucleus, electrons, you can say there is cloud of electrons. Means electrons revolve around the nucleus due to electrostatic force. Because of different polarities, they attract. Electrons revolving in the nearby orbits are closely bound with the nucleus. And electrons lying to the faraway orbits, especially in outermost orbits, they are loosely bound or weakly bound with nucleus. There is a less electrostatic attractive force, Coulombian force. So these outermost electrons are important for electricity and for electronics. If we supply some minimum energy to them, they can become free electrons. Electric field, heat, form of energy. Receiving this energy, these electrons can become free electrons. And these free electrons can be drifted through wires, can constitute current, important for our chapter number 3, current electricity, and chapter number 15, semiconductor materials, devices and logic circuits. So this is the important. How do we get these free electrons inside our electrical wires or in electronics? Now come to the main part. What are semiconductor materials? As you know, elements of the semiconductor materials are lying in the fourth group. If you see the fourth group, you find carbon, silicon, germanium. In this chapter, because basically our chapter is solid state electronics, means we will talk more about the solid state, crystal form, to make our devices. Nowadays you are knowing this common word LCD, liquid crystal display. That is the other part. But this is the basic of electronics. So here we will discuss the solid state electronics. Broadly, semiconductor materials are divided into two parts. Semiconductor materials. Intrinsic semiconductors and extrinsic semiconductors. What do you mean by intrinsic semiconductor? If you search this word intrinsic, the meaning is pure, and the meaning of extrinsic semiconductor is impure. So first we will discuss on intrinsic semiconductors, especially their crystal structure. Taking the example of silicon or germanium. You know the atomic number of silicon is 14. So the electronic configuration of silicon So in this electronic configuration, the inner orbit cells have 2 electrons, then 8, and they are bounded electrons, not useful for electricity or electronics. The outermost orbit has 4 electrons for a single silicon atom. So valency भी हम लोग बोलते हैं. And this outermost electron also decide the number of group. अगर आप first group है तो इसका मतलब outermost electron is 1. If elements are from the second group, so they have 2 free electrons. So 4 means it is from 4th group, and these are the valence electrons. Now in intrinsic semiconductor crystal form, some impurity will be there, 0.01%. By the refining process, we obtain silicon. Simply ये जो अपना रेती है, सी सैंड, उसके अंदर से आपको सिलिकॉन अवेलेबल हो जाता है. We have to perform some industrial process, refining, mining. तो हम लोग सिलिकॉन ऑब्टेन करते हैं. इसीलिए सिलिकॉन डिवाइसेस आर चीप कंपेयर टू जर्मेनियम डिवाइसेस. सोनी टीवी थोड़ा कॉस्टली है, तो हो सकता है कि उसमें दे यूज द जर्मेनियम, और कोई टीवी अगर सस्ता है तो बिकॉज ऑफ डिवाइसेस मेड अप ऑफ सिलिकॉन. कॉस्ट कटिंग, ये सब इंडस्ट्रियल प्रोसेस है. कॉस्ट कटिंग डिपेंड्स ऑन रॉ मटेरियल्स. So you are collecting these silicon atoms in a crystal form, solid form. These all silicon atoms will be very close to each other. It is important to look at the crystal structure diagram for silicon. This will be discussed in your next part 2. Again, I recollect the topics, discussion points of the today lecture. Definition of semiconductors, importance of electronics, areas, applications of electronics, basic structure of atom, some important points of semiconductor materials, and finally types of semiconductor materials to be continued.